So we saw in the last video that the division operation yielded a strange result. So we have the same numbers here. X is 10, Y is 3. The quotient, 10 divided by 3, should be 3.33 and so on. I am putting the quotient into a float, which could accommodate that decimal. But when we run the program, we find that we lose decimal precision. So we'll run that, take a look. So here it's saying 10 divided by 3 equals 3, which is not an accurate result. So what is going on here? What's going on is a phenomenon called integer division. And basically, an integer division states an integer divided by an integer will yield an integer result, period. It doesn't matter that we thought ahead and we tried to put the quotient into a float, which could have accommodated that decimal. It doesn't matter. By time the number gets into that variable, the damage is already done. Okay? So what we have to do here, there's a remedy, and the remedy is to use the what we call the static cast operator. Okay, this is called typecasting. So what we'll do is, if I want to keep these as integer, if I change these to floats, that would fix everything. It really would, because then it's no longer integer division. But I don't want to do that. I want to keep these as integers. I don't want to change the data types permanently. But what we'll do is we'll cast one of these. It doesn't matter which. Just take your pick. I'll do X because he's first. And what we'll do is we're going to typecast this to a float or a double, doesn't matter. So this is the static cast operator. And I'm going to cast X to a float. Okay, so the syntax is kind of ugly. And but that's how you do it. You use a static cast. You're saying, okay, I'm going to cast this variable X to a float. It's just temporary. It just takes place as this statement is running. It's like in the blink of an eye, a nanosecond. So as this statement is running, X is temporarily promoted to a float or changed to a float. It's like a magic wand, okay? So boom, just for this nanosecond X, you're going to be a float. And now we have a float divided by an integer, which is not integer division, which will give us the good result that we're expecting. It would be a 3.33 and so on. Okay, so let's see if that works. Okay, and then when the statement is over, X is still, it just goes back to being an integer. So again, this is just a temporary data type change just for the sake of this calculation so we can get the result that we want. So we'll go ahead and run that. And there you go. You can see we have our decimal precision. Okay, in a later video, I'll show you how to set the number of decimal places, but the fact is we did not lose our precision. We were able to get around the integer division phenomenon by using the static cast operator.